Greetings to each and everyone. This is Group 3. Today we're going to tackle about codes that includes the basic logic gates, encoding and decoding, and repetition and hamming codes. Today's topic is entitled The Enchantment of Codes, with the theme Breaking Codes for a Bold Future. And these are the objectives. First, to debate, recognize, and comprehend the nature of codes. Second, to master many sorts of coding techniques for encoding and decoding on information. And lastly, to use these strategies for identity, privacy, and security. Cracking codes and deciphering circuit communications requires a lot of math, from fundamental addition and subtraction to data handling and logical thinking. Let us talk about codes today and how they are used.
First, let's talk about basic logic gates. The basic logic gates. Digital systems are said to be constructed by using logic gates. There are 7 basic logic gates which are with the aid of truth tables. First is AND gate. The AND gate is an electronic circuit that gives a high output only if all its inputs are high. A dot is used to show the AND operation. Example, A dot B dot. Next is OR gate. Is an electronic circuit that gives high output if one or more of its inputs are high. A plus is used to show the OR operation. NOT gate is an electronic circuit that produces an inverted versions of the input at its output. It is also known as an inverter. If the input variable is A, the inverted output is known as NOT A. This is also shown as A or A with the bar over the top. NAND gate. In the figure shown, that is a NOT AND gate which is equal to an AND gate followed by a NOT gate. The outputs of all NAND gate are high if any of the inputs are low. The symbol is an AND gate with a small circle on the output and the small circle represents inversion. NOR gate, also known as NOT OR gate which is equal to an OR gate followed by a NOT gate. The outputs of all NOR gates are low if any of the inputs are high. The symbol is an OR gate with a small circle on the output.
XOR gate, a circuit which will give a high output if either but not both of its two are high. An encircled plus sign is used to show the EOR operation. 7. XNOR gate, a gate circuit that does the opposite to the EOR gate. It will give a low output if either but not both of its own inputs are high. In summary, the following figures and truth tables are presented.
Let's talk about text data. Textual data is material that has been methodically collected and consists of written, printed, or electronically disseminated words that have been either purposely written or transcribed from speech. Text mining uses statistics, linguistics, and machine learning concepts. Next is encoding and decoding. Encoding and decoding are employed in many types of communications, including computers and data transmission, communications, programming, digital electronics, and human communications are all areas of study. Encoding is the process of putting a message into a form that can be communicated representational design with the goal of ensuring that the receiver understands it. Decoding entails carefully listening to and reading directions. For example, you may realize you're hungry and encode the following message to send to your roommate. I'm hungry. Do you want to get pizza tonight? As your roommate receives the message, they decode your communication and turn it back into dots to make meaning.
Here we have few following that includes in encoding and decoding. First is errors and error corrections. The process of detecting faults in sent communication and reconstructing the original error-free data is known as error repair. It ensures that messages are received in a correct and error-free state. ARQ is an error control method that employs error detection codes as well as positive and negative feedback acknowledgement. The figure is an example of ARQ. Next is the error decoding codes. Error detection refers to the method used to discover noise or different impairments added into facts even as it is transmitted from source to destination. The oldest method of error detection involves the use of parity. It works by appending an additional bit to each character present.
A parity bit is a bit appended to the information of binary bits to make certain that the complete number of i's in the facts are even or odd. Parity bits are used for error detection and it has two types. First, we have the even parity. The number of bits with a value of 1 are counted. If that number is odd, the parity value is set to 1 to make the total number of ones in the set, including the parity bit, an even number. Second one is the odd parity. It refers to the parity checking modes where each set of transmitted bits has an odd numbers of bits. If the total number of ones in the data plus the parity is an odd number of ones, it is called odd parity. And the figure is a representation.
Next is repetition codes. Is one of the most fundamental error correction codes. To do so, the aim of the repetition code is to simply repeat the message numerous times over a noisy channel that may contaminate the transmission in a few spots. The figure is a representation of repetition codes. Next is checksum. Checksum is an error detection method that is a modular arithmetic sum of message code words of fixed word length. Checksum scheme involves longitudinal redundancy checks, parity bits, and check digits. The figure shown is a representation.
Repetition and Hamming codes. Hamming codes is an error correction system that can detect and correct errors when data is stored or transmitted. Error correcting codes seek to identify when an error is introduced into some data. This is done by adding parity bits, redundant information to the data. It is named after its inventor, Richard W. Hamming. What is an error? A transmitted data that can be corrupted during communication. There are 3 types of error. Number 1, single bit errors. The change made in 1 bit in the entire data sequence is known as single bit error. And number 2, multiple bit errors. In data sequence, if there is a change in 2 or more bits of a data sequence of transmitter to receiver, it is known as multiple bit errors. And lastly, number 3, burst errors. The change of the set's bits in data sequence is known as burst error. Hamming code structure. Recall that all bits positions that are powers of 2, example 22, 21, 23, are marked as parity bits and other data bits are 4 data bits. P7, P6, P5, P4, D3, P2, P1, 7 bits. The value of parity bits is determined by the sequence of bits that is alternatively as checks and skips. If the receiver did not get the correct message, there must be an error in the message. We can use Hamming code to detect and correct the error.
And now, let's have an example. A sender gives 4 data bit 1101 to a receiver. Determine the value of parity bits. Solution is shown in the figure. Find the values of each parity bits. Number 1. For P1, from P1, check 1 bit, skip 1 bit, check 1 bit, and skip 1 bit. And this is how you do it. Number 2. For P2, from P2, check 2 bit, skip 2 bit, check 2 bit, and skip 2 bit. This is how you do it. And number 3. For P4, from P4, check 4 bit, skip 4 bit, check 4 bit, and skip 4 bit. And this is how you do it. Since the sequence is only up to counting the number 7, then we will now determine the value of parity bits. To complete the structure, the sender transmitted the message below to the receiver. And the message received is 11001110.
Next, we are down to discuss the redundant bits. Redundant bits are extra binary bits that are generated and added to the information carrying bits of data transfer to ensure that no bits were lost during the data transfer. And the number of redundant bits can be calculated using the following formula. 2p is greater than m plus p plus 1, where p is equal to redundant or parity bit, m is the data or message bit. Let's have an example. Suppose the number of data bits is 7, then the number of redundant bits can be calculated using this formula. Thus, the number of redundant bits is equal to 4 bits greater than 12. Lastly is the repetition. When we say repetition, repetition of codes happens because sometimes one code may be repeated for every data bit and multiple times and can be checked if it was sent correctly. Conclusion. These codes makes math practical. By producing code for simple programs or automates machines, people are not only seeing the immediate results of their math work, and they're also learning a real-world skill. And that's all for today. I hope that you have learned something, and thank you for watching.